All right, greetings class. So we left off at standard form of a linear function. I need you to make sure you go back and review these three things. Okay, so starting with example 3, that's where we had left off. You're supposed to write an equation for the line in standard form. That's ax plus by is equal to c, that passes through the point -8, comma 3, and has a slope of 2. So first step, you want to put this in point-slope form. Point-slope form. You have your point, you have your slope. So let's revise. Our point-slope form is y minus y sub 1 is equal to m times x minus x sub 1. That is your point-slope formula. So now all we need to do is plug in our values. So y minus y sub 1, which is 3, is equal to m, which is 2, times x minus x sub 1, which is a -8. See what I did there? I used a parenthesis. Now, let's simplify, because we got to change this to standard form. We have a y minus 3 on the left is equal to 2 times x plus 8. Let's go ahead and apply the distributive property. So we're looking at y minus 3 is equal to 2x plus 16. Don't forget to distribute that to the 8 as well. Now you can go ahead and add 3 to both sides. When you add 3 to both sides, you're left with y equals 2x plus 19. But this is in slope-intercept form. This is in slope-intercept form. We don't want it in slope-intercept form. We want it in standard form. Okay, so continuing the problem up here, we're going to go ahead and subtract 2x from both sides. So we've got this y equals 2x plus 19. I'm going to subtract 2x from both sides so that I can get my variables on the left, my constants on the right. And I'm looking at a negative 2x plus y is equal to positive 19. But keep in mind, your a value has to be positive. It has to be positive. So I'm going to go ahead and multiply a -1 to both sides of my equation. When I multiply a -1 to both sides, remember to apply the distributive property on the left so that you're ending up with a positive 2x minus y is equal to a -19. And there you have it, your standard form. It satisfies all three conditions that all your a, b, and c values are integers, that your variables on your left, constants are on the right, and that your a value is a positive. Okay. Now we're going to do the same. We're going to write an equation for the line in standard form that passes through these 2 points. So, step 1, let's find slope. We need slope. Remember, your slope formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Label your points if it helps, darlings. X sub 1 comma y sub 1. And we'll call this x sub 2 comma y sub 2. Label your points. So now when we go to plug in, y sub 2 is simply 2. Minus y sub 1, which is a -3. Be careful, take care of your signs. Use the parentheses to help keep your work organized. Your x sub 2 value is a positive 7, minus, from your formula, x sub 1, which is also a -3. So when we go to simplify this, we are looking at 2 plus 3, which is 6, all over 7 plus 3, which is 10, reduce. Always reduce your fractions. You can reduce it by 2 and get a 3/5 for your slope. Okay, we've identified our slope. Now we're going to choose one point. I'm going to go ahead and choose 7 comma 2 because I like working with non-negative numbers. If you want to choose -3 comma -3, go right ahead. You're still going to end up with the same solution, same standard form. Okay, so point slope form, remember that? Can't forget it. Point slope form, y minus y sub 1 is equal to m times x minus x sub 1. Now that I've chosen a point and that I've found my slope, I can plug and chug. Y minus, I'm going to use y sub 2 instead of y sub 1, is equal to my m, 3/5, times x minus x sub 1. I'm using x sub 2. Remember, I'm using the sub 2's. 7. Okay, so now I can go ahead and apply the distributive property. Continuing the problem up here, I have y minus 2 is equal to 3/5 x minus 21/5. So just take that 7, put it over 1, multiply your numerators, multiply your denominators, and there you have it. But now I have to add 2 to both sides. So remember, this is where some of you tripped up in class when we talked about these kinds of problems. I'm adding 2 to both sides to get y by itself, okay? I want to get my constants together. But instead of adding 2, I'm going to add 10/5. Isn't 10/5 the same as 2? Watch this. Why am I adding 10/5? Miss K, where are you getting all these crazy numbers from? I'm adding 10/5. 10/5 is 2, so it's as good as me adding 2 to both sides. Now, if I'm adding 10/5 to the other side, look at that. I've got a same common denominator such that I can combine my fractions together. That's why I'm using 10/5. So these guys cancel. I'm left with a 3/5 x, and a negative 21 plus 10 gives me a negative 11 over 5. Okay, but it's still not in standard form just yet. It's in slope-intercept form. This is slope-intercept form, and we need to convert it to standard form. So here we go. Continuing the problem up here, I'm going to go ahead and subtract 3/5 x from both sides. So negative 3/5 x plus y is equal to a negative 11/5. So all I did was subtract this guy from both sides. Because remember, standard form, I need my x and y variables on the left-hand side, constant on the right. Well, my a value and my c value cannot be fractions. They have to be integers, okay? And my a value has to be positive. So let's clear the fraction. I'm going to go ahead and multiply a negative 5 to both sides of my equation. Multiplying this negative 5 to both sides, this negative and this 5, is going to help me get rid of that negative and clear the fraction. So the negative 5's cancel here, but then when I take that negative 5 and distribute it to my y, I get a negative 5y. So I'm looking at a positive 3x minus 5y is equal to positive 11. Remember, over here, your 5's cancel, your negatives cancel, because negative times a negative is a positive. Positive times 11 is a positive 11. And voila, there you have it, your standard form. If you need to pause, rewind, feel free to do so. Take a look at example 5. We've got a couple of things going on. Let's talk about our horizontal line. Horizontal lines are y equals some number. That number is 1, 2, 3, 4, 5. And the green line, that's going to be a vertical line. X equals some number, negative 1, negative 2, negative 3. And you have to write an equation in standard form. Okay. So we're going to take this, y equals 5. and put it in standard form. It has to be a 0x. Agreed? Plus y, 1y, the coefficient on y is 1, is equal to 5. 0 times x is 0. 0 plus y is y. And all you do is keep bringing down your equals 5, and that's what you end up with. So in contrast with your x, you have a 1x, right? Your coefficient in front is a 1, plus 0 times y is equal to a negative 3. There's your standard form. So 1 times x is x, plus 0 times y, which is 0. That's x plus 0 is x, equals negative 3. You end up with what you started with. Therefore, your standard form would be this guy here. Okay. Next page, example 6. You're supposed to write an equation in standard form of the horizontal line and vertical line that pass through the point 3, negative 5. So let's go ahead and start with y. Y is equal to a negative 5. Your x value, we'll do it in dark green, x is equal to a positive 3. So just like what we did in example 5, we're going to do the same thing in example 6. Here we have a 0x plus y is equal to a negative 5. Standard form. Remember, standard form is ax plus by is equal to c. And over here we have x plus 0y is equal to 3. Okay. Now let's talk about writing equations of perpendicular lines. So non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. So folks, you're going to want to bust out that highlighter. Perpendicular if they're opposite reciprocals. So in example 1, take a look. The slope of line 1 is negative 2/3, and we are looking for the slope of line 2, which is perpendicular. So that means I need to take the opposite reciprocal. The opposite of a negative is positive, and then the reciprocal of 2/3 will be 3/2. Over here, the opposite of a positive 2 is a negative 2, right? But the reciprocal of 2 would be 1/2. So just take this guy, put him over 1, and then flip him, reciprocal. Opposite of negative is a positive, and this is negative 1 over 1, so it's just now positive 1 over 1, which is just positive 1. Over here, you have a positive 1/5. The reciprocal would be negative 5. Opposite reciprocal. Okay, take a look at examples 2 and 3. Are the following lines perpendicular? And then we have to explain why or why not. So in example 2, zooming in, we have a negative 3 and a positive 3 slope. If your slope here is negative 3 and your slope here is positive 3, they are not perpendicular. They are not opposite. I mean, they are opposite, but they're not opposite reciprocals. So while they are opposite, yes, opposite, no to reciprocal. So they are not opposite reciprocals. They're just opposite. In example 3, one is positive, the other is, this is negative, sorry, and the other is positive. And they are reciprocals. So yes, these guys are perpendicular. Because yes, they are opposite, and yes to being reciprocals. So opposite signs, and then when we talk about reciprocal, if you're going from 4/5 to its reciprocal, it should be 5/4. So just keep that in mind. Opposite signs, and you must flip your fraction or whole number. Okay, so now we're going to write an equation of the line that is perpendicular to y equals negative 3x plus 2. So identify your slope. Your slope is negative 3 here. The opposite reciprocal would be a positive 1/3. So this is the slope we're working with. This is the point we're working with. Point slope form. Point slope form, and whenever it says write an equation, we want it to be in y equals mx plus b format. So let's go ahead and start by putting it into point slope form. Point slope form is y minus y sub 1 equals m times x minus x sub 1. Plug and chug, here we go. Y minus 3 is equal to 1/3 times x minus 2. So I just plug these in for x sub 1 and y sub 1, and I plug this in for my slope. Now simplify. Y minus 3 is equal to 1/3 x minus 2/3. I need to add 3 to both sides, right? I got to add 3 to both sides, but folks, instead of adding 3, I'm going to add 9/3. I'm going to add 9/3, and I'll show you why. 9/3 is 3. But when I add 9/3, which is 3, they would cancel. When I add 9/3 over here, I want it to have the same common denominator, which is y. I chose 3 as my denominator. So when I add 9/3 over there, I'm left with y equals 1/3 x plus 7/3. Careful of your signs. Negative 2 plus 9 is a positive 7/3. Now let's make sure we read the instructions carefully. Write an equation. So we're going to make sure it's y equals mx plus b, and we did. We're not putting it in standard form. It doesn't say to put it in standard form, so there you have it. Okay. Example 5. Let's go back and revisit parallel lines. Folks, parallel lines have the same slope. So we're going to write an equation that is parallel to y equals 2x minus 8. Identify your slope. Your slope is 2. So we're going to use the same slope and plug it into your point slope form. Identify your x sub 1. Identify your y sub 1. And your slope is 2, so let's plug and chug. Y minus y sub 1, which is 5, is equal to your slope, which is 2, times x minus x sub 1, which is a negative 3. See what I did there? Parentheses, apply the distributive property here. So now we're looking at y minus 5 is equal to 2 times x plus 3. Apply the distributive property again, and you get y minus 5 is equal to 2x plus 6. Add 5 to both sides. And now you have your line that is parallel to your given. Y equals 2x plus 11. Your y-intercepts will be different, of course, right? But your slope, 2 and 2, should be the same for parallel lines. So on the next page is a summary of equations of lines. It is your responsibility to know these. And then this, I would like for you to fill out. I will put the answer key on Google Classroom, but I want you to fill out to the best of your ability and then come prepared to class with any questions you may have. All right, see you in class.